Good morning, students. What are you seen in the previous class, ma? In the previous class, what is work? What is work? How work done by a constant force? How to calculate the work done by a variable force? And what are the three cases by applying the work? When the work it will be zero, okay? And then what is the energy? What are the types of energy? What is the work kinetic energy theorem? And then that all are discussed in the previous session. In the today's session, I will explain types of potential energy. Already I explained in the previous session what is potential energy. What is called potential energy? Potential means one work done by an object. Okay, work it will be done by an object. That the object it will be moved from one point to another point. Definitely that the object will be having some potential, having some energy, that it will be called as potential energy. Potential energy not to be stored in a rest object, that the energy is, it will be the work it will be converted into energy, that the work it will be done to try the object from rest position to another one position. Okay, that will be called as potential energy. So potential energy is nothing but work it will be converted into another form of energy, that will be called as potential energy. So various types of potential energy in your book have it. So one is first, what is the formula for potential energy? Potential energy always represented by a symbol is capital U. Okay, capital U is equal to integral of work formula is will be same for the potential energy. What is the work formula? Force into displacement. So force into displacement, that is Fa dot dr. Fa mean one object will be considered, that is A. That will be acceleration, having some acceleration, that will be denoted as A. So Fa dot dr. Okay, that is the work done formula. Work done formula only it will be stored as a electrostatic potential, stored as a potential energy. So the potential energy it will be formula, it will be nearly same for the work done. So integral of F dot dr. So that is the potential energy formula. Okay. So three ways the potential energy it will be developed. What are the types of three potential energy? One is gravitational potential energy. Okay. Second one, elastic potential energy. Third one is electrostatic potential energy. Okay. So three types of energy is there. One is gravitational potential energy, elastic potential energy. Third one is electrostatic potential energy. What's the meaning? That gravitational potential energy means one work it will be done, work by an object, that the object it will be moved upwards against the gravitational force. By using the gravitational force, the energy to be developed, that the energy it will be called as gravitational potential energy. Elastic potential energy means the energy it will be having by a spring, or energy it will be possessed to the string. So one string will be having some energy, that will be called as elastic potential energy. The string always is having some elasticity power. So that it will be called as that the string will be having some energy, that the energy will be called as elastic potential energy. And third one is electrostatic potential energy. What's the meaning? That electrostatic potential energy? One electron will be moving in an atom. The electron definitely will be having some energy. That why only the electron will be moving to the atoms, are revolving around the nucleus. So that the electron having some energy, that the energy will be called as electrostatic potential energy. Clear? So three types of energies. One is gravitational potential energy, elastic potential energy, and electrostatic potential energy. Especially electrostatic potential energy means work it will be done to bring a unit positive charge from infinite distance to one point against electric force. For example, consider one charge. Okay, that is a positive charge. Consider one charge. We want to bring one another positive charge. Some electric force is there. Okay, we want to bring the another one charge from the infinite distance to the near point of the first charge. So we one object or one thing it will be one work it will be done by an object to bring the unit positive charge against electric force. It will be called as electrostatic potential energy. Electrostatic potential energy na onnu illa, ஒரு சார்ஜ் பக்கத்தில் இன்னொரு சார்ஜை particular distance வந்து கொண்டு வர்றதுக்கு தேவையான work, that will be called as electrostatic potential energy. So electrostatic potential energy is nothing but to bring as a unit positive charge from infinite distance to a particular point from the first charge against the electric force. It will be called as electrostatic potential energy. So okay, now I will explain the gravitational potential energy. Gravitational potential energy means all the object will be falling down because due to the gravitational force of the earth. Okay, suppose one object we try to move the upward against the gravitational force, that the phenomenon gravitational potential energy it will be present. So we have to try to one object, some work it will be applied to the object, that the object it will be take from the ground. Okay, so the object will be lying in a ground. Okay, we do some work, the object will be in a ground, we do some work, that the object will be moving upward against the gravitational force, that will be called as gravitational potential energy. Okay, so gravitational potential energy formula also same, integral of f a dr, f dot dr automatically a vector dot b vector is equal to a b cos theta. So f a dr cos theta, clear, f a dr cos theta, that will be expansion for the scalar product of two vectors. So f a dr cos theta, and then we apply the limit is 0 to height, because ground side does not to be displaced, the object does not to be displaced. So the first initial position is 0. Finally he covers some height from the ground. So the ball or object will be covering distances h. So 0 to h is the limit. Then we apply the limit to the phenomena. We consider one object will be moving upward against the gravitational force. So automatically the angle it will be parallel with one another. So the angle between the object and the ground is 0 degree. So cos 0 value is 1. So automatically integral of 0 to h f a cos 0 value is 1. So f a dr dot 1, sorry, r into 1, anything. So we taking f a as a common. Okay, and then 0 to h f a. So force, gravitational force formula is, what's the formula for gravitational force ma? 0 to h, f is the normally m into acceleration. This phenomena we taking the acceleration due to gravity. So m into the acceleration it will be put to g. So m into g and dr. Okay, so mg it will be taking at the outside as a constant, and 0 to h dr. Okay, so integral of dr is equal to m a integral of dr common r 0 to h. Okay, mg not a mg. So mg upper limit is h, lower limit is 0. So automatically the formula is mgh. This is the gravitational potential energy formula. U is equal to mgh. So gravitational potential energy is equal to m into g into h. Clear? So gravitational potential energy is nothing but work is done by an object, that the object will be moving upward, or the object will be take upwards from the ground. Okay, so one work it will be done against the gravitational force, that it will be the object will be having gravitational potential energy. So gravitational potential energy formula is energy is equal to integral of 0 to h f a dr cos theta. Theta it will be taking 0 because the object will be carried out to the carried from the ground. The angle is 0. So the angle 0 we know down, cos 0 value is 1. So integral of 0 to h f a dr. Okay, so we put the force value, we write the force value in this integral part. So the force value, force formula is m into g. G is acceleration due to gravity. So m into g into dr, and mg in the integral we taking at the outside because it is a constant value. So mg will be taking at the outside. Close integral of 0 to h into dr. So integral of dr r. So r, the limit is 0 to h. First applying the upper limit minus a lower limit. So mg upper limit is h, lower limit is 0. So multiplying with the upper limit and lower limit, mgh minus mg0. So mgh only. So U is equal to mgh. This is the gravitational potential energy. Next we will go for elastic potential energy. Already I told that what is the meaning with that elastic potential energy? We are taking one spring, okay. We have to apply the string, it will be attached, one side it will be attached with a rigid support, and another one side we have to apply one force, that it will be called as deforming force, okay, or restoring force. We apply force on one end of the string it will be stretched. We have to remove the force on force, it will be applied on the string automatically it will be going to the original position. That the force it will be acting on the string, it will be called as restoring force. So restoring means restoring force. One force it will be used to retain the size of the spring. Okay, so that is will be called as restoring force. Restoring forces will be always taken as minus kx. How? Minus kx means the string is there, it will be fixed as a rigid support. Okay, the string it will be fixed as the one side. One force it will be applied to the one side. So the force it will be applied, the object it will be displaced. Okay, the force it will be applied to the we pull the object, that the object only the distance it will be increases. Suppose we have to remove the force that will be applied to the string, automatically the spring it will be going to the original position. So negative displacement is there, that the displacement it will be denoted as minus. So minus kx is the restoring force formula. ஒரு ஸ்ப்ரிங்கை நீங்கள் இழுக்கிறீங்க அப்படின்னா அது வந்து நீங்கள் அப்ளை பண்ணக்கூடிய ஃபோர்ஸ், அதனால அதை விட்டுட்டீங்க அப்படின்னா அந்த ஸ்ப்ரிங் வந்து அகெயின் வந்து ஒரிஜினல் பொசிஷனுக்கு போயிடும், அதுக்கு பேர் ரெஸ்டோரிங் ஃபோர்ஸ். அகெயின் ஒரிஜினல் பொசிஷனுக்கு போகுதுன்னா நீங்கள் ஃபோர்ஸ் அப்ளை பண்ணக்கு ஆப்போசிட்டாக மூவ் ஆயிருக்குன்னு அர்த்தம். ஸோ தட் வில் பி equal to the minus k into x. X is the negative displacement. So x it will be denoted as minus. So minus F is equal to minus k into x. That it will be the formula for restoring force. Okay. So we substitute the formula in the integral part. So integral of f into dx into cos theta. We taking only the force value, not a restoring force. So the force value is k into x. So f value is kx into dx into cos theta. Effect kx into dx into cos theta. Normally the force formula is f into dr cos theta, but f value is having x, that why only the dr it will be changed into dx. Okay, so kx into dx into cos theta. Already we taking theta is the zero angle. So zero angle means the thing will be moving by the applying force direction. So both the direction it will be in a x-axis position. Both the force and thing movement it will be done in parallel. So theta angle it will be 0. Okay. So we taking kx as a common. Okay. And then cos 0 value is 1. So cos 0 1 value. So kx is outside and integral of 0 to x into dx. So integral of dx x. So kx and x we applying the limits 0 to x. So k into x into x. Okay, x minus 0 automatically x only. So kx square. Okay, this is the elastic potential energy formula. Elastic potential energy is equal to kx square. This is gravitational potential energy, U is equal to m into g into h. This is elastic potential energy, U is equal to k into x square. Okay, elastic potential energy is having the restoring force. Restoring force is nothing but the string it will be having some force, it will be retained their original position. That the force it will be called as deforming force or restoring force. That the restoring force F is equal to minus k into x. Minus it will be indicate that the object, by ignoring the force, the object will be moving in a negative direction. So automatically the negative sign it will be incident on the force formula. So F is equal to minus kx. We substitute the F value and then we substitute the limit value, and then we easily calculate elastic potential energy U is equal to k into x square. Okay. Next we will go for, already I told that electrostatic potential energy. Okay. Now I will go for force and displacement graph. How to draw the graph is in between the force and displacement. We have to apply one force, okay, that the object will be moving. We want to plot a graph is in between the force and displacement, okay. This is the force, okay, this is the this is the force, this is the displacement. The force, it will be considered as restoring force, elastic force, okay. So restoring force means that's the formula is kx, okay. Force, it will be applied continuously and constantly. The displacement, it will be done. We want to calculate the area under the graph force and displacement, that the area, it will be indicate the what amount of force it will be acting, what amount of work it will be, FDR we want to calculate. So automatically what's the work it will be done by applying the force, and then what's the energy that the object will be having, this is also easily calculated by using this graph, okay. So this is one triangle, this is one triangle. Force ko neenga displacement ku graph potrீங்கனா, that the graph, that the area it will be covered under the graph to form the triangles, that the triangle it will be easily, it will be used to calculate the work acting on the object, and then energy having an object, that will be easily calculated. So area is equal to, area of the triangle formula is half into A into B, half into area into breadth. So half into area is the covering distance, that is will be called as area, so x, and then breadth, that is kx, okay. This is one triangle and this is one triangle. We want to calculate the area of this triangle and area of this triangle. This angle base is breadth into height or base into height. So base is x and height is f. So half into x into height, height is kx, half AB, half breadth and a height. So we easily calculate the area, that the area it will be used to find out the work done, it will be in object, and then find out the energy also, okay. This is the graph, it will be explaining the relation between potential energy and displacement. Potential energy displacement means potential energy and kinetic energy, it will be nearly same, but it will be opposite with one another, okay. We want to draw the graph versus kinetic energy and potential energy and displacement, okay. So versus energy and displacement, one object is having some energy, the object covering some displacement, so that the two values will be taken to plot a graph. So displacement will be taken as x-axis and energy will be taken as y-axis. Two energy will be acting, one is kinetic energy and potential energy. Kinetic energy and potential energy, this is the kinetic energy, potential energy, this is the kinetic energy. Potential energy means first initially that the object will be in a rest position, automatically the energy it will be increases, automatically the object it will be moving, and particular point again it will be reaches the potential energy, and again it will be the potential energy it will be increases, okay. இந்த இடத்துல நீங்கள் ஸ்டார்ட் பண்ணி பொட்டன்ஷியல் எனர்ஜி டிக்ரீஸ் ஆகிட்டே வந்து இந்த இடத்துல மேக்ஸிமம் பாயிண்ட் அட்டன் ஆகி, and then it will be again, it will be reversely, it will be increases. Then that's the same way the thing will be in a rest position, the kinetic energy it will be increases, reach the maximum point, and it will be decreases. So potential energy and kinetic energy it will be vice versa. Vice versa means it will be perpendicular with one another. So one increases, automatically another one decreases. One reaches the maximum point at the one side, another one reaches the maximum point at the opposite side, okay. So this is the relation between potential energy and displacement, okay. Then two question in my book, that is a very interesting question, that the two question it will be explain the object movement having some velocity and potential energy. So first question is, how can object move with zero acceleration? One object will be moving, okay, definitely will be having some velocity, definitely having some mass, definitely having some acceleration. But question is, how can object move with zero acceleration? One object will be moving, okay, having some velocity. One force it will be applied to the object, that the object will be moving. Oppositely, one force it will be applied to the body, the object having some mass, having some speed, that will be continuously it will be in a motion, isn't it? Yeah, because one force it will be applied to the one side, that the object will be moving, the opposite external force it will be applied to the body, the body it will be some disturbed and then automatically it will be moving in a constant velocity. That the point the net force it will be 0 because that the force will be applying forward, that the force will be applying backward. So the two net forces will be now acting in two forces will be acting opposite with one another. The net force to be 0. Net force 0, automatically the acceleration to be 0, but that the object will be moving forward. Clear? So that is will be that's the concept it will be using. How can move within 0 acceleration? That the time that the object will be moving having some 0 acceleration, because 0 acceleration means that the concept that the point the force net force it will be 0 because one force it will be applying forward, another one force it will be applying opposite side of the movement of object. Okay. And second question is, why should the object be moved with constant velocity when we define potential energy? Often we taking constant velocity to explain potential energy. So that's the question is, why should the object be moved with constant velocity when we define potential energy? So always we take a constant velocity to explain potential energy. Why? So that is the question. Okay, why? So I will explain. First, we consider one object. Okay, that the object will be moving, having some velocity. According to the work energy kinetic theorem, change in kinetic energy it will be equal to the work done. Okay, okay. According to the work energy principle, change in kinetic energy it will be equal to the work done. Okay, but one object it will be created from the potential energy. We are taking the three types of potential energy. One is gravitational potential energy, elastic potential energy, and electrostatic potential energy. That's a three potential energy does not impact any kinetic energy, does not change the any kinetic energy. Okay, but due to the principle of work energy, kinetic energy will be changed into create the work done. Okay, not it will be possible. So that's the that the potential energy does not impact the kinetic energy. So not to be considered as the kinetic energy not to be changed. Kinetic energy it will be constant. What's the formula for kinetic energy? Half into m into v square. Okay, kinetic energy not to be changed. So how can velocity to be changed? Kinetic energy change agalana velocity ungalku change agala. So the kinetic energy will be constant by applying the gravitational potential energy and elastic potential energy and electrostatic potential energy, because that the all the energy does not impact any kinetic energy. So kinetic energy will be constant. Automatically the kinetic energy formula is half into m into v square. So the velocity to be constant. So often we taking constant velocity of an object to explain the potential energy. Okay, because the potential energy does not impact any kinetic energy. Clear? Okay. This is the two questions. The two questions is very important and then very interesting facts also. Okay. In the today's session I explain again. I will recall all the concepts. First one is what is potential energy? What is potential energy, ma? Work done to bring an object to move from one point to one position to another one position. Work done. Potential energy is always it will be equal to the work done. Work done by an object it will be always stored as a potential energy. Okay, so potential energy U is equal to integral of work done formula, that is FA into dr. So that is the potential energy formula. Okay, energy unit, potential energy unit also Joule. Okay, then there are three types of energy: gravitational potential energy, elastic potential energy, and electrostatic potential energy. Gravitational potential energy means work it will be done to move an object upwards against the gravitational force. Okay, so automatically against the gravitational force means the formula it will be given, and 0 to h limit it will be applied, and 0 to h FA dr, theta angle is 0 because it will be parallel with one another. So theta angle is 0, automatically cos 0 value is 1. So FA dr into 1, 0 to h f value is mg into dr, and mg will be taking at the outside, and 0 to h dr. Okay, so we are taking integral of dr is r. So mg integral of dr r, the limit is 0 to h, mg the upper limit minus lower limit. So the gravitational potential energy is equal to m into g into h. Then elastic potential energy is equal to, elastic potential energy means the energy it will be possessed by a string, okay, string or spring. Yes, we apply the force on the string will be stretched. After removing the force, the string it will be goes to the retain their original position. That the retain one force it will be act, that the force is restoring force or deforming force, that the force it will be equal to minus kx. The negative sign indicates that the object it will be displaced in opposite direction. The negative displacement is there, so the opposite sign it will be mentioned with the force formula F is equal to minus kx. We substitute the force formula and we easily calculate potential energy, elastic potential energy U is equal to k into x square. Okay, and electrostatic potential energy means electrostatic potential energy work done to bring a positive charge from infinite distance to particular point, okay, against the electrostatic force. Electrostatic force ku against ஒரு unit positive charge ஒரு infinite distance இருந்து கொண்டு வரதுக்கு தேவையான energy, that it will be called as electrostatic potential energy. Okay, and then force into displacement graph. Force into displacement graph it will be tells the what's the work, what amount of work it will be done, and that the work done will be converted into potential energy, that is will be elastic potential energy. And then we draw easily the graph between force and displacement. The area covered below the force and displacement, that the area making some triangles. The area of the triangle is equal to half into base into height. The base is x and the height is kx, so half kx square, okay, half into kx square, that is the formula for elastic potential energy. So this is the formula for elastic potential energy. Okay, so half kx square. Then easily plot the graph between potential energy and displacement. We taking displacement as a x-axis and we taking energy as a y-axis, and kinetic energy and potential energy of the particle it will be noted down, that the two energy it will be opposite with one another. One it will be reaches the maximum point at the one side, another one reaches the maximum point at the another one side. So the energy it will be having the maximum point and having the 0 point will be opposite with one another. Okay, total energy will be calculated adding the potential energy and kinetic energy. Okay, this is the graph is between the displacement and the energy. And then two interesting question is there. One, how can object move with zero acceleration? One object is will be moving forward motion by applying force, another one opposite external force it will be applied to the body. The net force it will be acting on the body it will be 0. So net force it will be 0, automatically the object is having zero acceleration, but the object will be moving forward. Okay, so this is the way we easily explain how can object move with zero acceleration. And second case is, why should the object be moved with constant velocity when we define potential energy? We consider the three types of potential energy. One is elastic potential energy, and gravitational potential energy, and electrostatic potential energy. In the three cases does not impact any kinetic energy on the object. So according to the work energy kinetic theorem, change in kinetic energy develop the work done. So no change in kinetic energy is there. Kinetic energy it will be constant in the phenomenon of potential energy explanation. So potential energy explanation, automatically no change in kinetic energy, so velocity does not to be changed. So the object will be considered with constant velocity to explain the potential energy. Okay, so this is the today topics. So first one, how to define the potential energy, gravitational potential energy, elastic potential energy, electrostatic potential energy, force and displacement graph, potential energy and displacement graph, and two interesting phenomena. Okay, today home assignment. Home assignment for today's session. Learn and write the elastic potential energy. Okay. Today home assignment, learn and write the elastic potential energy. Okay. Thank you.